So we've been looking at different types of chemical reactions, and this sort of summarizes. This is classifying reactions by looking at what happens. My pointer's messing up. Because of chemical reactions, there's precipitation, there's acid-base reactions, there's gas evolution reactions, and there's a little asterisk here. Many gas evolution reactions are also acid-base. And then there's oxidation reduction reactions. Combustion reactions are a subcategory of that. So just like many things in real life could be put into more than one category, sometimes chemical reactions fit into more than one category as well. Another way to classify chemical reactions is by looking at what the atoms are doing, looking at the pattern of the reaction. And so here we're going to give slightly different names. This is a synthesis or combination reaction. And the identifying feature of this is you have two or more reactants combining to form one thing. It's a combination. You've got multiple reactants combining into one product. Combination reaction. Decomposition. That's the opposite. It's not combining, it's decombining. It's taking apart. And so for this one, we have one reactant decomposing, coming apart into more than one product. Then we have a displacement reaction. This is sometimes called a single displacement. So here we have one element plus a compound. So this is like a guy who shows up at the party by himself. And this was a guy and a girl that came together. But in the course of mingling, the girl decides that this guy is finer than the guy she came with, and so she leaves with him, right? And then this guy has to go home by himself. It's very sad. It's very sad for poor guy B. But it happens. Double displacement is a little happier because here two couples came, but they mutually agreed and switched partners. Okay? And we've looked at a lot of these types of reactions. The precipitation reactions were double displacement, both switching partners. The acid-base reactions were also switching partners. Okay? The gas evolution reactions were switching partners mostly. So let's talk through these really quickly here. Synthesis, two simple compounds combining to form one, more complex. So here we have sodium metal and chlorine gas. Both of those would be dangerous to ingest. You combine them together and you get table salt, which in moderation is good for you. It's a combination. You took two elements and combined them into one compound. It would be a redox, yes. And so one of the things that bothers a lot of students is we can put one reaction into more than one category. But you can put cars into different categories too, right? Well, this car, so my husband has a Honda Fit. So it's a four-door, and it's blue, and it's a compact, right? So it falls into lots of different categories. So don't let that bother you too much. Decomposition. We're taking a complex substance, breaking it into simpler ones. So here's the battery in the water. Passing electric current through water, we take this one reactant, H2O, and we end up with two products. We're taking it apart. We're decomposing it. Decomposition. Displacement, single displacement. So here we have a piece of zinc metal, and if we put that into a solution of copper chloride, chloride prefers zinc. And so she will draw the zinc out, and then the copper gets deposited onto this, and you'll see the silvery zinc strip turn copper colored as this exchange occurs. And then double displacement. This is probably the most common one that we see. So precipitation reactions, acid-base reaction, gas evolution reactions are all double displacements. So this is the flow chart for that method of classifying. Those 4 guys there. So we should be able to look at an equation and classify it. This will be multiple choice on the exam, and I will not try to trick you. Now, in the homework, they may try to trick you, but I'm not going to try to trick you. So here are the categories: synthesis, decomposition, single displacement, or double displacement. Pick one for each. So this first one, what's going on there? Single displacement. Aluminum is coming by himself, and here's hydrogen with phosphate. Now aluminum is leaving with phosphate, and hydrogen went home alone. Single displacement. So SD for single displacement. How about B? Copper sulfate plus potassium hydroxide. That's double displacement. The copper and the potassium are swapping partners. How about C? Synthesis. One product. Dead giveaway. Synthesis. And how about this one? Decomposition. One reactant, multiple products. Okay? That's not too hard, is it? Yes?
Is combustion decomposition even though there's two?
Combustion is not decomposition. Because there's 2 reactants, and a decomposition, there's only 1 reactant. So combustion reactions don't fit into these categories super well. Probably the best description would be a single displacement, because you've got oxygen by itself and this other compound. But it doesn't even work really well there. And so that's one of the reasons we have 2 methods of classifying reactions, is because one of them doesn't work the best. We need both of them. Any other questions? So there's chapter and review. Those are the things you should be able to do. Oh, and there's more examples.